3, 2. What's up? My name is Juan.
And I'm Chris.
And this is the ME110 Porter Cable 18 gauge nail gun.
You gonna learn today.
How it's meant.
The Porter Cable BN125A 18 gauge brad nailer is a finishing nailer commonly used by construction companies for the installation of baseboards, crown molding, and other finishing features. This nail gun is renowned for its durable construction and exceptional work performance in almost any condition. As we disassembled the nail gun, one of the first things we noticed was that the tool was not designed with disassembly in mind. All threaded parts had thread locking compound applied and were considerably torqued. The main motivation in having done so was probably due to the nature of the tool's intended purpose. A nail gun's task applies large impulses on itself through the action of the internal hammer driving the nail into the workpiece. Therefore, we conclude that the application of the thread locking compound was to prevent the parts from coming loose and possibly causing injury. For the tool itself, it is built around a cast aluminum outer casing. This casing makes up the handle and main body of the tool. Molten aluminum is poured into a cast. The liquid metal takes on the form of the cast. The metal cools and the cast is then removed. The casing is then post-machined to add internal threading. Threads are usually added by turning the workpiece against a cutting tool. The thread pitch is determined by the feed, which is distance per revolution. In this particular case, the workpiece isn't suited to being turned because it isn't perfectly round. So instead, to add the threading, a tap acts as the cutting tool and is turned inside the casing. And then the end cap that connects the nail gun itself to the airline is threaded externally using a tap. The handle acts as a storage for compressed air at approximately 100 psi. When the trigger is released, a valve opens and the air moves into the piston chamber. The piston is made from an aluminum head that has been turned down on a lathe. This is evident by the small marks left by the cutting tool on the surface of the piston. Connected to the piston head is a hardened steel punch that was likely forged. The purpose of this punch is to translate all the downward force generated by the compressed air in the piston onto the head of the nail. From the hardness of the punch, we can guess that it was cold worked. This process seems appropriate when considering the amount of stress that the punch is put under during a typical work cycle. The spring-loaded slider rail is responsible for loading the following nail after one has been ejected. Judging by its geometry and being made from aluminum, it is likely produced by extrusion. Extrusion is an excellent process for mass production because of its high yield and relatively low cost in making completed parts. Extrusion usually produces parts with acceptable surface finish and therefore no post-machining is required. All of the plastic parts, the trigger, the backstop on the end of the slider rail, and the plastic tube that guides the piston head are all made of plastic. This is likely because plastic is inexpensive to produce and because of its low melting temperature. These parts were likely made by injection molding. Upon closer inspection, one can see what appears to be a parting line where the two halves of the injection mold were joined together. Modern day manufacturing utilizes these different processes, and the end result is a quality product that is very useful to the consumer.